In this video, I want to take a look at identifying the domain of a couple different functions. So for the first function, we have 2x plus 3. When we're talking about domain, what we want to know is for what x values does this graph exist on? And another way you could think about this is if you were going to graph this, is there any sort of restrictions of when you're graphing it along the x-axis? So if I had like a corner grid here, and I were to graph a function, is there anywhere that it doesn't exist? Meaning that I have to indicate some sort of hole, or maybe there's like an asymptote where it's approaching the asymptote or doing something like that. Like, is there any sort of restriction? So in the first one, 2x plus 3, if you think about just 2x plus 3, is there any restrictions on 2x plus 3? No. So the domain for 2x plus 3, like if I were to graph 2x plus 3, it would just be a line, and there's no stop to the line. It goes on forever, negative direction, goes on forever in the positive direction. So the domain is all real numbers. So negative infinity, positive infinity, all reals. So there's nothing that's going to cause any sort of issues for 2x plus 3. Now the next one, 4 over 2x minus 3, what do we know about expressions where we have this variable, the x, in the denominator? What we can't have is we cannot have 0 in the denominator. So we cannot zero out a denominator. So what we're going to have to do then is we're going to have to figure out for what x value would zero out our denominator. I just want to point out something real quick. If I had a problem like this, if I were to ask you what's the domain of a function like this, x over 3, there's no restrictions here. X over 3, there's no issues here with this graph because there isn't a x in the denominator. So I want you to pay attention to why we're setting this one equal to 0 and why we wouldn't do it for that one, because the x is in the denominator here. So we want to navigate that. So we're going to set the denominator equal to 0. I'm going to solve for x, add 3 over. I get 2x equal to 3. Whoop, let's divide by 2, not 3. So we're going to divide by 2, solve for x. So we get x equals 3 over 2. What that means is that for when x is equal to 3 over 2, we are going to zero out the denominator. We can't do that. So that means the domain is everywhere but 3 over 2. So I could write this as negative infinity up to 3/2. With a parentheses, because we don't want to use a bracket, because a bracket would indicate that the domain exists at 3/2, but we want to use parentheses because the domain does not exist at 3/2. So x cannot equal 3/2. And then union that with parentheses 3/2 out to positive infinity. So any other number is perfectly fine for this domain. We could plug in any number, negative 1,000, anything, and it would be okay besides at 3/2. So x cannot equal 3/2. So everywhere else but 3/2. And then if you wanted to investigate this a little bit more, you can graph it, see what's happening at 3/2. But that would just be an asymptote at x equal to 3/2. Okay. Last one, square root of 2 plus 3x. So when we have a radical like this, what we can't have in a radical is negative numbers. So we can't take the square root of a negative. So that means that I have to take this radical, 2 plus 3x, and figure out for what x values will it be greater than or equal to 0. Because we could have 0. 0 is okay. The square root of 0 is 0. So that's fine. But we can't have negative. So we want to make sure that our x value, for what x values would keep our radical here greater than or equal to 0. So then we're just going to solve this. 3x greater than or equal to negative 2. Divide by 3. X greater than or equal to negative 2/3. So let's just go back and talk about this just a little bit more for a second. I'm going to go ahead and plug in negative 2/3 into my radical here just to show you what happens. So when I plug that in, I get 2 plus 3 times negative 2/3. So what happens is the 3's cancel. So I get 2 plus negative 2. 2 plus negative 2 is 0. So I get the square root of 0, which is 0. So that's fine. So for any value of negative 2/3 or greater, that is going to be the domain. So the domain is from bracket negative 2/3 out to positive infinity. So any value greater than or equal to negative 2/3 is going to be in our domain of this function of square root of 2 plus 3x. And just think about the logic. Like if you were to take a couple more points, like 0, x equal to 0. What is that? What happens there? 3 times 0 is 0. 2 plus 0 is 2. Square root of 2. That's fine, and so on. And you can keep going. But anything less than that, if you go on the left side of negative 2/3, like if you take negative 1, negative 1 would be 3 times negative 1 is negative 3. 2 plus negative 3 is negative 1. Square root of negative 1. Then we're in a different number system, and things get a little bit more complicated. So that's not going to be in our domain. So that's why we want to start at negative 2/3 and go out to infinity. So I hope this helps with identifying the domain of different functions. There's a lot of different scenarios that you could take a look at, but for this video, I just took a look at some more common scenarios that you would see for identifying domain.